Good morning. My name is Anush. I'm a program manager with Operating System Security. And today I'm going to talk to you about Windows Hello and the new things we've done in the anniversary release. Maybe it's better to start by giving you context of why we did Windows Hello. Every day we hear yet another headline about an organization being breached. The latest one being the U.S. Office of Personnel Management breach. And most likely we'll be talking about this for years to come. The reason for that is this was not an ordinary attack, and the sensitivity of the information. Oh, let me actually put this slide into slideshow. Okay, let's give it one more shot. And then from the current slide. Hopefully it's not going to slideshow from the beginning. All right. All right, perfect. Yes, so as I was saying, the most recent attack was the United States Office of Personnel, where what was interesting about this was the type of data that was stolen. It was ranging from, starting from names all the way to personal information for everyone or anyone who has ever get cleared from this office, including the president. As you can imagine, this shows that there is new sets of attacks that are targeting government organization. And that's not the only one. We have seen other attacks that are targeting high-profile users. The case of, let me actually progress this guy. Huh. It's not working. Let me see. What's going on here? Let's give it a shot from here. Huh. Do you happen to know what's going on? And show. Maybe try one more time. Okay, it seems that it's working now. Okay, great, thanks. So as I was saying, the types of attack that we have seen has also started targeting individual users. In the case of Mark Zuckerberg, it was an interesting one. His account was part of the LinkedIn data breach. And as part of that, the attackers get access to his password, and then they managed to actually replay that against his other social media accounts like the Twitter or Pinterest. And it turns out that he was using the same password across all of the same website. And so his identity was lost. And so as you can see from this, these recent breaches that we have reported in the past, the impact of these attacks are closely tied to how the user identity is protected. The user identity in this case being the username and password. But what is wrong with username passwords? What makes them inherently insecure? It's the fact that the username password is basically one factor. It's the only thing that you need to become the user from anywhere in the place, anywhere in the network. So all I have to do to attack you is to basically figure out your password. And because it's a shared secret between you and the server, anybody who can guess it or take it from you or ask it from you, or if you unintentionally share it with anybody, they can actually be you. And so it's a commonly known problem. Obviously passwords are easier to use because it's only one thing you need to remember, but they're not secure. There are existing solutions, and this is a well-known solution in the industry to solve this problem, is to move from one password to two-factor, from one factor to two-factor. And what that means is basically requiring the user to present more than one proof that is them. The problem with them is these kind of solutions normally tend to be costly and hard to deploy and manage. So one is secure, one is hard to deploy, and also for users, they're reluctant to take over something that doesn't have a good UX. So the only way to make it work is to make sure the solution is both secure and also can provide convenience for the user. And what a better segue to Windows Hello than this. So what is Windows Hello? What is it trying to do? In summary, Windows Hello is a built-in two-factor authentication in Windows that addresses the complexity and the cost challenges that the existing two-factor solution possess. It leverages the device as one of the factors for user authentication, and by doing so, it provides the same convenience as password because the user already have their device. As a second factor, it leverages either a 4-digit PIN, or in some cases, if the enterprise wants it, a more complex PIN, in addition to a biometric gesture to authenticate the user in a two-factor authentication. Now, it does that, but it also comes at the same level of enterprise-grade security as existing two-factor authentication solution like smart cards. In contrary to smart cards, however, it provides a much better provisioning experience and also deployment. It can be provisioned electronically, meaning that you don't have to issue ID cards or readers or fobs for this to work. When we designed Windows Hello from ground up, we wanted to make sure it's a password alternative, but we also wanted to make sure it doesn't suffer from any of the problems that password does today. In summary, it's supposed to be protected against breach attack. And the way we achieve that is by leveraging asymmetric cryptography. Because it's asymmetric, there's no symmetric secret that you share with any server. So if one server gets compromised, your credentials are safe. It's also protected against theft. The reason for that is the credential is actually tied into your device, so the attacker cannot steal it from you. And because it's using asymmetric cryptography, it's also protected against phishing attacks. So an attacker cannot lure you to provide your credential. One of the things that Windows Hello comes with is a built-in single sign-on experience. So it's built into the Windows, so you don't have to deploy a custom third-party solution to get single sign-on experience. And finally, it already integrates with Azure AD and the AD/AAD hybrid environment where you have an AAD Connect, and it just works out of the box. It also works with Microsoft Account. So when you set up your device in Windows 10 setting, you're already leveraging Windows Hello for authenticating to MSA. So when you're buying an app from App Store, Windows Hello is actually being used on the back end to authenticate the user. So that's basically what Windows Hello is. And this diagram does a fairly good job explaining what happens under the cover. The user starts by typing their PIN or providing a biometric gesture. That PIN or biometric gesture is then verified by the system, by the device, and is used to unlock what we call a logical container. This logical container is where all the credentials are stored. And the gatekeeper for all of this is the TPM, or the Trusted Platform Module on the system, that protects this credential, and that's the thing that provides us protection against theft. And so this is a kind of a high level explaining how Windows Hello works. And the reason why it's a two-factor authentication is because both this part, the PIN or a biometric gesture, and this part, which is a key stored on the device, are required before the user is authenticated to a backend. So that's basically context of what Windows Hello is. And the type of things it's trying to protect. In summary, it's a two-factor authentication that tries to solve what passwords are suffering today. We believe that it provides the same convenience, if not better, than password, because the user does not have to have two different things. It's only their biometric gesture. But it also solves the problem with the password because it's a two-factor authentication. So that's Windows Hello. That's what it does. That's basically the reason why it was introduced. Now, coming to what this talk is about. We have few sessions today at Microsoft Ignite where we're going to talk to you about the new stuff that we've done for Windows Hello. In today's talk, in this part one, if you will, we're going to cover 5 areas, actually 6. No, it's actually 5. The first one is the support for fingerprint in Windows Phone. We will then talk about some of the improvements we've made in terms of the enrollment. We have made the user experience more with more feedback, so the user can know where they are in terms of enrollment. We will then talk about the support for Windows Hello in Microsoft Edge, which is based on FIDO specification. We then talk about a new member of the Windows Hello family called Companion Devices. And we'll wrap this up by talking about the improvements we've made in terms of security for Windows Hello. These are the 5 areas that we'll be focusing on. There are other sessions that will happening today and on Thursday that talks about the deployment part of this today. And then on Thursday, talking about the API story behind Windows Hello. All right, so let's go through them one at a time. First topic is support for fingerprint on Windows Phone. So Windows Phone have already supported biometrics in the form of iris, and that's something that we shipped with 950. But in the anniversary, we are proud to announce that Windows Phone now supports fingerprint. In my hand, there is an HP phone, HP Elite phone, that has a biometric sensor on the back, sitting under the camera. And the way it works is I can simply touch the sensor, and then that will unlock my phone. The only way I can show you right now with the setting that I have, many PCs around, is by showing you the screen, but you can see how it works. So I'm going to go ahead and touch my finger on the back. As you can see, without actually, and as soon as I do that and I lift my finger, it actually logs me into my phone. As I put my finger on the sensor, it vibrates real quickly to say, the authentication was successful and you're in. So that's one way that fingerprint is integrated into Windows Phone Unlock. What I'm going to do next is actually show you how fingerprint can be used to purchase an app from the App Store. And if you remember, let me actually disconnect one of these guys from the Miracast, because that's how I can present. And if you remember, as I mentioned earlier, Microsoft account is now aware of Windows Hello. So when you buy a movie from the Microsoft Store or you download an app from Microsoft Store, on the back end, what's happening is that the Microsoft account is authenticating you to the backend server, so Windows Hello can be used in that case. Let me try to. Oh, maybe this guy is sitting on it. For whatever reason, this guy is not finding the conference room for presentation. 6, 7. Okay, it might be this guy. Yeah, there you go. I had to disconnect this laptop. So let's try one more time. So what you're about to see is how the same experience for store purchase will look like with the fingerprint. And the thing to keep in mind is that the user does not have to enroll their finger in different places. They enroll it once when they set up their phone, and then it will just start working everywhere. So let's go back to 6. There you go. So the screen, this part of the screen, let me do it this way. So this is basically projecting my phone screen. So I'm going to go ahead and launch Store here, and then navigate to Movies and TV, just as an example. The internet is a little bit slow here, I guess. And let's say we pick one of the rentals. It really doesn't matter which one. Okay. There you go. So just pick one of these guys. And when I click on rent, and I decide which kind of method to use for downloading it, what's going to happen is that Microsoft account will try to authenticate me to the store. And this UI shows us, asks me to scan my finger. So I'm going to do the same thing with my phone that I did last time, put my finger on it. And as soon as I get authenticated, then I can go ahead and decide on the purchasing and what kind of card to use. So that's it. Same finger that was enrolled once can be used across unlocking your phone or buying an app from the App Store. And if there is an app that leverages Windows Hello, you will see exactly the same experience. And so the key point we're trying to make is making sure that from a user perspective, they always see the same user experience when they have to interact with Windows Hello. So there you have it. Let me go back to my main screen. So that was basically fingerprint support in Windows Phone. Next is the improvements we've done in terms of enrolling their finger. One of the feedbacks we got when users were interacting to enroll their finger was that it's not quite clear what the next step is. It's not quite clear where they are in terms of enrollment. So we made some changes to the enrollment experience to show the user the progression of their enrollment. And here's how it's going to look like. So the user clicks on Enroll, clicks on Get Started. They have to type in their PIN. And after that, then the new experience kicks in. This is where, as you can see with this visual guidance, we tell the user in terms of the strikes that was received and how far they have gone. The dark blue color shows the progression. And if they have to change the angle, the same graphics can be used to tell the user how to touch the sensor and how to move their finger. So that's also something that we believe that's going to help the user understanding how to finish the enrollment experience, which should be under 10. All right. So that's topic number 2. The third thing I want to talk about is Microsoft Edge support for Windows Hello. And this is where we kind of took a standard approach to this. When we started Windows Hello, we wanted to make sure we build something that is a standard. It is something that we do it with the industry. And we wanted to solve the password problem not in a Microsoft-only way, but also across all services and platforms that the user interact with. That is the reason why Microsoft joined FIDO, and we have been contributing to their specification on how to standardize this new type of credential. FIDO is a big consortium of companies, and the number of members is growing every year. As you can see from the names on the board, we have all the brands and big names in the industry that are part of this, and it's a very focused group of companies that really are trying to aim at killing passwords. And one of the specification that FIDO has published is a specification on web authentication APIs. And that specification was submitted to W3C, which is the standard body for standardization of browser APIs. And we took a snapshot of one of those specs, earlier spec, and implemented it in Edge. So this is now available, and developers can start playing with those APIs. However, as any other standard work, the specification move on and they change, and we'll continue adapting our implementation to the latest spec. So what you see in anniversary release is going to change in upcoming release as the specification rectifies. But what I wanted to show you, and there is a dedicated session about these APIs on Thursday, which you can go and check it out. But what I wanted to kind of show you is how the experience will look like if one interacts with with Microsoft Edge that supports Windows Hello. So here's a quick demo of this. It's a website that we put together. There's actually a link on the PowerPoint, so feel free to check it out yourself later. But basically, here's one experience one can build. The user logs in with username and password. They're promoted to start using Windows Hello. And if the user decides to actually do so, clicks on Start Using Windows Hello, then they can either type in their PIN or swipe their finger And at that point, a keeper is registered for that user with the server. So when the user comes back next time to log in, all they have to do is to just click the button, and the same experience, either type in their PIN or swipe their finger, and they're logged in. And that's all it takes. As you can see, this is kind of the next thing in the authentication space when it comes to websites and browsers. It's a seamless experience. And you saw how that experience looked like on Windows Phone when I was trying to buy an app from the App Store. Here, I also put together this one just as a point of reference. This is going to show you a similar experience for Dropbox, which is an app on Windows. And the way Dropbox works is that you can set it up such that every time you launch the app, it actually leverages Windows Hello to make sure it's you before it shows the content. One thing to keep in mind is, remember the experience you saw for browser, you're going to see the same thing here. So launch the app. In this case, the face is being used. And as soon as user is authenticated, he can see the contents. Again, same user experience, same design language across all of them. So phone, PC, browser, app, all the same, similar design language. All right. As I mentioned, there is a session on Thursday at 10:45 that deep dives into the APIs behind apps and browser. If you're interested, please join those, and we can talk about it more. All right. So that was the third topic of the day. The fourth one that I want to talk to you about is an extension that we have made to Windows Hello in the form of companion devices. So just to give you context of why we thought this is important, when you think about a user and the kind of devices they carry with them, they normally have a phone in their pocket. Mostly they have some kind of a wearable on their arm, a smartwatch or a fitness band that they carry. Some of them might have these security fobs that their company would give it to them, which they have to use to log on to enterprise resources. And many of us carry a badge with us, and that is used to go through the doors and get access to different physical locations. And the thing we kind of wanted to do is leverage these devices as a way to know it's the user, right? Right now, we only support a PIN or a biometric gesture to do that, but what stops us from start using this as a way of knowing it's the user? And the beauty of this is the user normally has a phone in their pocket, right? So it would be great if you can leverage that for different reasons. In terms of the scenarios that we wanted to kind of start leveraging these devices, we had two in mind, and we have built both. One is when the companion device is acting as a second factor. This is, in this case, the credential continues to be on the PC, but the companion device is just a PIN or a biometric replacement. So it's great for devices without biometric support, or for users who want to build experiences that are not possible with biometric. And you'll see some of the videos about that. The second one is, and the second mode of operation is when the companion device is actually like a smart card. It has both of the credential and the second factor together. And in this case, you can take it to any of the PCs or network resources and be able to log on with them. So the way to kind of visualize them, one is a one-to-one relationship between the PC and the companion device. That's when the companion device is only a second factor. And the other one is a kind of a portable credential mode. It's a one-to-many relationship where the same companion device can be used to access different PCs. And the way, and not all companion devices can act in both modes. The one where you have a one-to-many relationship requires certain crypto capability from the companion device. Obviously, when you're giving out enterprise credential to a device, it needs to be able to protect it, and not all devices can do that. Whereas on the left-hand side, where you have a one-to-one relationship, the requirement in terms of crypto is less. So while a phone can act as both, some entry-level fitness bands cannot act as both, just to give you some idea. Now, we have built solutions in both categories. The only one that we have on the one-to-many relationship is a phone solution, but on the left-hand side, we have a larger set of solutions. Now, I just want to call it out that the solutions that plug into the second factor mode, which is one-to-one, it doesn't mean that they couldn't fit into the one-to-many. It's just that we haven't made the second one extensible enough for everybody to plug into. The first one is more extensible. So this is another way to represent the same thing I just said, right? This is the basically. This is the second factor extension where we have expanded the PIN and biometric to companion devices. And the way to look at the portable one, the one that has both credential, it's almost you take all of them. So your credential goes on the phone or the companion device. And then the companion device also asks for a PIN or biometric or whatever it takes to verify the user. And that's basically the difference, right, where the credential is. OK. So I have a demo for the case where you have a portable credential. The only solution we have right now that supports this is a Windows Phone solution. The kind of scenario for that it was trying to enable is replacing smart cards with your phone. And it basically is designed with keeping in mind that not all PCs have TPMs, and I wanted to provide that TPM functionality for such devices. A Windows Phone always have a TPM. It's also a portable two-factor authentication solution, which is ideal when you have encryption certificates that you want to leverage and you want to have it on one device that you carry with you. And also because the phone supports biometric, it's similar to having a biometric roaming solution because you enroll on your phone once and then you can leverage that biometric experience across any PC you come into. If you notice for Windows Hello, the biometric requires that you enroll on each PC individually. But with this one, you only enroll once and then you can use it across different PCs. So it provides certain value propositions that maybe a PC cannot. And again, the idea was, if you have something in your pocket already that you're using for other reasons, why can't you leverage it for authentication scenarios? So as I mentioned, the goal was to make it such that it's a smart card replacement. And we basically went after those scenarios and tried to basically enable them the same way a smart card would do, right? And today, smart cards are used for things like VPN connection, logging in a browser, logging into your PC. And we actually have gone and enabled most of those scenarios already with this solution. So the first one that you're going to see, and it's going to be hard to demo because they're two different devices, is the VPN connection. So let me go ahead, and I want to call out for this solution to work with VPN. You don't need to upgrade your VPN profiles or solution. It would just work out of the box with it. And I explain how it actually works for you to know why this is the case. So let me go ahead and go to network, and I'm going to go ahead and I have 3 different profiles here because we're testing with stuff, but normally that's not the case. So when I click on connect, this thing is acting up. This is using my credential on the system. So let me actually go ahead and delete my credential so it actually reaches out and use my phone credential. OK, that should do it. So what's happening right now is that the PC is trying to log on to the VPN connection, and it figures that there is a certificate on the phone that it can use. It asks me to approve this request from my phone, and if I touch my finger and log on my phone, the connection will go ahead and succeed using the certificate on this phone. Now, just to reiterate what just happened, the PC tried to connect me to a VPN connection, and for it requires a certificate. It did have a copy of a certificate from my phone that was transferred to the PC at the time of pairing. And so I picked it up and I tried to use it. There's enough logic in the Windows to know that this certificate is not stored locally in the system, it's stored on the phone side. And that's where I got a notification on my phone that says, somebody's trying to access this certificate, are you okay with it? And I said yes, and then it asked me for my PIN or biometric to know it's me. And then once I provided my fingerprint in this case, then the certificate was accessed over Bluetooth, and then the PC can get a signature over Bluetooth. The keys are not exchanged over Bluetooth, it's just that the Bluetooth is used for exchanging the signature or requesting a signature or decryption. And then once the right signature is received, then the PC can leverage that and connect to the VPN. And because we made it such that it works with existing certificates, your current VPN deployment would just work with this without any changes. Same experience if you had a website that can log the user using certificates. The same thing would work in the same manner. So that's one use case that we have enabled with this. The second one is logging into the Windows with your phone. Again, very similar to what Smart Card do. So let me go ahead and show you this experience, maybe using this time the phone side. Try to connect one more time. So what you're about to see is how the logon experience would look like if I were to use my phone. And what they have done, I have created a dedicated tile from my PC. If you can see, this tile here belongs, it actually is associated with the PC that is sitting over there. And it has this name that was assigned by the network. I can change that name if I want to. And all I have to do is unlock my phone with touching my finger and then click on this icon. And what it does, it basically logs me into the PC over Bluetooth. And again, the thing that happens, it's hard to see, but the thing that happens under the cover is Bluetooth connection is used to, oh, this one is falling down. Bluetooth connection is used to perform, and the logon succeeded here. I'm not sure if you can see. But basically, again, Bluetooth connection is used to perform decryption, figuring out the cache verifier that we need to log on, and then continue. So there you have it. You have logging into Windows, being able to log on, to connect to a VPN connection, and also logging in browser, all using phone over Bluetooth. OK. So that's one mode of operation. And what that was, again, was the case where we were leveraging the companion device as a portable credential, very similar to smart cards. We talked about the case where a companion device can be used as a second factor to provide the convenience of Windows Hello. And this is where we make the framework extensible and pluggable. And as part of that, we have partnered with a few companies that plug into this and actually build an end-to-end experience. And what you're about to see in this video is how those experiences would look like. I do have demos also for some of these, actually for all of these guys. I'll try my best to do it, but given that the number of PCs involved, that might be a bit tricky. So let's see how that goes. The first one is from a company called HID. HID Global provides solutions around secure identities. They provide cards, and they're very popular for physical access. Within Microsoft, we use their solution to provide physical access through the doors and buildings. And one of the latest solutions that they have is plugging into our framework, which we call it Windows Hello Companion Device Framework. And this, what allows you to do is to leverage the employee badge to unlock a PC over NFC. And this allows the user to use the same thing they already have in their pocket to go through doors, to also go through Windows. So let's see what they have built.
Today, we'll have a look at the HID Global Sign-In app for Windows 10 using an iClass CS card. The HID Sign-In app enables you to use the same credential that you use for physical access entry to sign into your Windows 10 PC or tablet device. To get started, download the HID Sign-In app from the Windows Store. Once the HID sign-in app is installed, I'll register my iClass CS card to my PC. To register, I'll enter a pairing code to securely communicate to the card. Then simply tap my card to the contactless reader and enter my Windows PIN to prove that it's me registering a new companion device. The registration process is complete. To demonstrate the HID sign-in app in action, I'll lock my PC. To unlock, I simply tap my card to the contactless reader. Now, anytime I want to unlock my PC, I only need to tap my card to unlock it. If your PC does not have a built-in contactless reader, HID offers a wide range of desktop readers for your every need. To learn more, visit us at hidglobal.com.
All right, so that's one solution. And again, it provides two interesting new things that we didn't have before, right? It works over NFC, which our phone sign-in solution doesn't work on, and also provides you with a form factor that you might already be giving the employees and they might already have in their pockets. So real quickly, let's see if I can show you this one. So this is one of the readers, and which I have connected to this PC over USB. And as you can see, there is a string here that says, tap your card to log on. And right there, that's as easy as the logon would be. One of the things that you may notice is that these solutions are leveraging the same design language as Windows Hello. You see the same strings above the lock screen and the same kind of happy face and all that. And that's because they're part of the Windows Hello family. So that's one of the solutions. Let's move on. The next one that we have is from Yubico. Yubico manufactures a hardware authentication device. They called it YubiKey. This device supports multiple authentication and cryptographic protocols. Some of the protocols they support out of the box includes OAuth, smart card authentication, and signing, as well as authentication protocols like FIDO ones. And the thing that you're about to see is a solution they built. We also demoed this yesterday using companion device framework.
Welcome to Yubico. With the Windows 10 anniversary update, you can now use companion devices like the YubiKey to authenticate with Windows Hello. Currently, companion devices can only be used to unlock a Windows 10 device, which we will now demonstrate. To start with, we need a supported YubiKey, which can be purchased from a Yubico store or Amazon. To enable companion devices, we need to set up a user PIN under Windows Settings, Accounts, Sign-in Options. Next, you'll have to go to the Windows Store to download and install the YubiKey for Windows Hello app. Launch the app, click the Register button to add a new YubiKey for account unlock. Then we insert our YubiKey into a USB port. After assigning a name to our YubiKey, we authenticate with our PIN or Windows Hello biometric gesture. The YubiKey is now registered to unlock this user account. Now, when the screen is locked, we can insert our registered YubiKey, touch the YubiKey button, swipe up on the screen, or press any keyboard key. The authentication happens in the background, and we have unlocked the computer. To learn more about how to set up your Windows 10 device for unlock with YubiKey, go to yubico.com/Windows Hello.
All right, and so this is an experience using a USB port. As you can see, we have NFC, USB, and we'll see something for Bluetooth. And because, the reason why we got all this solution out of the market real quick is because we made it extensible, and our partners are doing a great job building into it. So we can also quickly look at that and how that looks like. So I have a YubiKey already inserted into this PC, and all I have to do is simply touch a button on it. Sorry. Oh, how's that? Oh, sorry, I registered the wrong one. So actually, it's good to see the whole end-to-end experience. So just going to give it a name. And then continue. I have to provide my PIN. And all set, finish. So let's go ahead and give it a shot. Tap your, there you go. So touch of a button, and you're logged in. So that's the second one that you saw. Using a USB port and a security dongle. And again, this company provides these dongles for many other protocols. It's not just for this reason. You can also use it in a smart card manner as well. All right, so let's move on to our next partner, Nimi. Nimi is a company that is headquartered in Toronto, Canada. They're 5 years old, and their first product is a wearable that actually I'm wearing right now. It's called Nimi Band. So this band is a wearable device that leverages the heartbeat, or ECG, for authenticating the user. And the way that works is when you clip it around your wrist, you hold your finger on it, and it basically figures out it's you, and it kind of gives you a feedback with a haptic feedback that is authenticated. As far as you wear the wearable, the device remains in that state. And if you clip it off and take it off, then it goes back into an unauthenticated state, so somebody else cannot pick it up and become you. This device works over BLE and NFC, and they've also built a solution with our companion device framework. They leverage BLE in this case. So let's see how that looks like.
Today I'm going to walk you through a demo of how the Nimi Band, which is a Windows Hello companion device, can be used with the Windows Hello companion device framework in Windows 10. The first step to use the Nimi Band with any application is to authenticate to the device. I'm going to do this using the Nimi Band's Heart ID biometric, simply by placing my finger on top of the band's sensor and matching my heartbeat to the template that's on the band. The band sends me a haptic notification to confirm that I have successfully authenticated. Next, I'll go to the Windows Store to search for and download the Nimi Companion Device app. After downloading, I will then open the Nimi Companion Device app to register my Nimi Band. To do this, I click Register Nimi Band, which triggers a light sequence to appear on the band. I will then enter the light pattern shown on the band into the Companion Device app. This process uses a Diffie-Hellman key exchange that ensures I am in fact registering the correct Nimi Band. I then hit confirm, and I'm prompted for my Windows PIN to complete the registration. I'll now test the application by locking my PC. To unlock it, I simply tap the Nimi Band to show intent, and my PC unlocks.
Oh, that video stopped shorter than I thought. There is a website, nimi.com. That's where you can get more information about where to buy their devices. I also have a demo of their solution. So let me go ahead on 6. There you go. So I'm already wearing a Nimi Band that has already been authenticated. So when I put it on, I put my finger, and so I did that. The other interesting thing about this solution is that also you can use they have a companion app on a phone, an Android phone. So you can use authentication on Android phone to also get authenticated to here. So you don't have to technically do this all the time. If your phone is unlocked, you can use the app to also transfer that state to their band. Now, either way, once the band is authenticated, the user comes to the screen. If they hit the space bar and the band is found, it asks me to double click, which if I do, sometimes they have to hold oh, sorry. I think this is taking me too long. Time. Oh, the pin is incorrect. Well, we did all this work for you not to remember pin. I think that's one of the outcomes. So let's try one more time. Looking for demand. There you go. This time it worked. Oh, sorry. There you go. Sorry, I was just not holding it correctly. So the double tap on the NIMI band allows me to unlock the PC, as you saw. And the key point here is that the user is in control in terms of deciding when to log on, because they actually provide the intent on the band. So that's the third solution. So you saw something on NFC, USB, and Bluetooth. The solution requires using a dedicated dongle that they ship with. And this actually provides them some interesting properties in terms of how they leverage Bluetooth, preserving privacy and similar manners. So that's that. The next solution that we have is coming from RSA. Let me just pose this real quick. So RSA are in the business, they also provide security solutions, including for identity assurance and access management. They also plug into the companion device framework, and doing so has allowed them to extend the access control that they had to Windows 10 logon experience. So you're going to see how that experience actually looks like.
Partnering with Microsoft and leveraging the companion device framework for Windows 10, RSA enables seamless and secure unlock of Windows 10 machines, depending on the required identity assurance level and contextual data, driven by administrator policies. In this example, a user on a public network with their smartphone nearby will be required to provide a gesture on their smartphone to verify their presence or identity. On a trusted or corporate network, the screen unlocks automatically when the user's smartphone is near their laptop and the user intends to unlock it.
So the interesting thing about what they've done is that be aware of the context in which the phone is actually being used to unlock the PC. In the cases when the phone is within the corporate environment, the friction is less, but as the user walks out of the corporate environment, the user will see an extra friction, which is unlock your phone first. So that kind of allows the enterprise or an app developer to build, different types of experiences because they're in control of when the unlock happens. We'll talk about the details on how this works a little bit later, but I want to call out that the list of partners that we have with companion device is actually a large list. Here's some examples that they're building apps into this framework and try to build end-to-end creative solution for authentication space. Now, how does this actually work? So as I mentioned earlier, this is the only framework that we have right now that is pluggable. And the way it works is that a partner should build a UWP app that talks to a new service and a credential provider in the system. And this app is also responsible for talking to the companion device. And because these two boxes are coming from the partner, they can pick whatever transport or media they want. And that's why you saw NFC, USB, Bluetooth, and all different experiences. So this is where the flexibility comes into play. As to how this app and this service talk to each other, it's pretty formalized using some public WinRT APIs. In terms of how we recommend our partners build this, we kind of wanted to make sure that the experiences they build is very similar to Windows Hello. And when you want to enable as communication between two devices, you need to think about how do I start, how do I find the one I want to talk to, and how do I disambiguate. So we wanted first that the user be in control, right? Just because two devices being nearby doesn't mean that they have to start talking to each other. So we wanted to have some kind of intent that the user actually wants to do unlock. In the case of NIMI, the intent was a double tap I did on the band. In the case of Yubico, it was the touch of the sensor. But we always want to make sure that user actually provides some kind of intent that they're okay with this operation. Then if the companion device can be paired with multiple devices, multiple PCs, we wanted to have some kind of disambiguation signal, which tells which PC you want to unlock with this companion device. So we recommend that our partners build that into their experience. And finally, the companion device ideally should verify that it's the user who's providing the intent to actually unlock, right? And that's where the user presence signal comes into play. In terms of how the whole user experience works, as you saw in the video, the thing starts by users setting up a PIN on their PC, and then they have to download an app from the App Store. And once they download the app, and this app can be a multi-purpose app. For example, if you have a fitness band, then it normally comes with an app to set up the fitness band for other reasons. The same app can be leveraged for this, right? So you don't have to download 2 different apps. So the app is used to register the device. And then once it's registered, then the user can go ahead and start unlocking. So that's basically the flow the user has to go through before starting this companion device. Short note on security management and policy. So the way we designed this policy, this framework, was to make sure that the companion device only talks to the PC that it was registered with, and also the PC only talks to the companion device it was registered with. We didn't want to take dependency on the transport layer security, so we built our own security on top of that. And the way we did it was through some kind of HMAC key operation, which is shared between the PC and the companion device at the time of registration. As such, it's important to protect those keys, whether at the time of creation or when you're using it. And so we kind of have some guidelines of how those have to be protected, and we kind of enforce them as part of certification program we have for these companion devices. We also want to make sure that the companion device verifies the user, and we recommend that they do it in a way that is unique, the same way as our biometrics. In terms of management, the user manages the solution through the app, right? So you saw with the YubiKey, there was an unregistered bottom, and all others have the similar concept, right? So all the management happens in the app and not in the OS. And finally, in terms of policy, we kind of support the big on and off switch for this solution. By default, this is turned off on all enterprise-owned devices, and it's turned on all consumer versions, right? So we check to see if the device is domain joined, we turn this off. We believe that this is an opt-in that the enterprise should do and decide on what companion devices they support depending on their security guidance and policies. Revocation, the way we think about which devices can get into an environment is using some kind of app locker model, right? So you have a whitelist of apps that can be deployed, and those are the apps that can talk to the companion device. And if a device becomes untrustworthy, you just remove that app from the app locker and it's revoked. All right, so that's a kind of a lengthy introduction to Windows Hello Companion Device Framework. And I think the key takeaway is that there are many creative solutions that are coming to market, and we're trying to kind of provide this device sign-in as an alternative to the biometric sign-in. And in terms of price range, compliances, and the support cost, we believe that this gives you options. And so the ecosystem is growing. We'll keep you posted as we get new partners and showcase the new experiences. So the last topic of the day is doubling down on security. So I wanted to kind of brief you in on what we have done in the anniversary release, increasing the biometric security in Windows platform. And I want to start on how we have made our biometric templates more secure. So biometric template is basically a kind of an abstraction of your biometric data. And the biometric template itself is not useful to an attacker because there's no raw information about your biometric data that we store. It's a kind of a one-way hash of that data. And the way we stored it is actually we stored it in a protected way. Today we use encryption. And you cannot use the template to reverse engineer the actual biometric data. As I mentioned, the templates are they never leave the device. They're never given to any app or any browser. They're just there for the operating system to consume. And when the user provides the biometric at the time of unlock, the OS is the one who actually verifies them against the template. Before anniversary release, the templates were stored encrypted to the local system account. And in the anniversary release, what we have done is start adding, leveraging the VBS, which was discussed yesterday, to also protect biometric data. Now, if you have heard about this, great, but if not, VBS or virtualized-based security is basically a new trust boundary within Windows. It provides a secure environment for execution that is separate from OS, and also it provides enhanced protection against attacks, even at the malware that is running at the kernel mode. And it's perfect for things, protection of secrets, which is what biometric templates are for. And so the thing we've done in anniversary release is to leverage that framework and also leverage a TPM 2.0, which is becoming a requirement in all new devices shipping Windows 10, to move all of our template and template matching into this environment. So what does that mean if the template and the template matching algorithm is run in that environment? It provides us with some interesting properties in terms of preventing attacks. One is because the matching engine now runs in VBS or VSM, then the outcome of the matching result cannot be spoofed. So even if you have a kernel mode driver, it cannot change a no to yes answer. Also, because the templates are stored in the VBS, it is protected against injection of templates. So if you even have an admin or a malicious admin on your system, it cannot inject its own template to the system and pretend it's you. And obviously, because this VBS does not give out your templates, it also protects against stealing templates. In terms of deployment, the secure matching and template storage is automatically enabled if you have the VBS if it's on. And the way VBS is turned on is there's you need Hyper-V and you need Secure Boot to be running. So as far as VBS and Secure Kernel is turned on, the biometric service in the system start leveraging it to protect the template. Now, in terms of policy, we have started running a program called Windows Hello Certification Program. And the goal of this program is to make sure that the bar for the biometric sensors that plug into Windows Hello is held high. And we have published certain requirements around what that means. And I wanted to leverage this opportunity to kind of walk you on some of those requirements and what a potential IHV have to go through before the biometric sensor is certified. One of the things that we have done with the anniversary release is making sure that anti-spoofing is a requirement for all new devices. And they have to provide that before they get certified. Also, for fingerprint, as I said, there's no policy. Every sensor has to support it. Face does have anti-spoofing policy that you have to set. Previously, the experience for anti-spoofing in face was that you have to shake your head. One of the updates we've made in anniversary release is that we have made it such that you don't have to do that anymore and you still get anti-spoofing going on. And so that's one of the, and it's using enhanced anti-spoofing algorithms behind the scene. And that's one of the things that we have done to make you such that this policy can be set more easily. One of the feedbacks we got was turning the head shake takes enough time that you end up using PIN. Now, before I go to the next requirement, which is around false acceptance rate and false rejection rate, I think we should kind of set the base on what that means. False accept rate is basically the odds or the probability that somebody else is recognized as you. And false reject rate, or FRR, is, there's a typo there, is basically showing like what's the possibility of of you not being identified as you, right? And this is a notion of how reliable the sensor is. You can make a sensor super secure by not letting anybody in, right? So that's not good. You want to kind of strike the right balance between security, which is false accept rate, and reliability, which is false reject rate. And the way we do that is when we set our requirement, we set a set for reliability, normally at 10%. And then we say, well, go ahead and measure your false accept rate. So here are the requirements that we have published for our sensors to follow. For fingerprint, depending on the size of the sensor, they either have to comply with 1/50,000 false accept rate or 1/100,000 if it's a larger sensor. For swipe sensors, it's the same as the small area sensors. So those are the things that we enforce across all new sensors that want to go through our program. For face, we only have one requirement and the same thing as 1/100,000. These are new sensors that are coming, so we don't have to have that table with 3 rows. And the false reject rate is set as 5%. And as part of the Windows Hello certification program, we have a driver signing program where this is where we enforce our requirements. The developer has to create a biometric sensor, obviously, and self-validate our requirements using those, and then they pass the HLK and fill out the security review template, send it to us, and we submit it and sign it. So that brings me to basically end of this presentation. We covered 5 things today, and I want to kind of reiterate what we just discussed, right? We showed how Windows Phone supports fingerprint with anniversary release. We also talked about the improvement into fingerprint enrollment. We talked about how Edge supports Windows Hello using FIDO APIs. And we also talked about companion devices and how they have expanded Windows Hello experience to new devices. And we finally talked about how we held the bar for security when it comes to Windows Hello and how we held the bar for ecosystem in terms of sensor quality. And I want to encourage everybody to join Windows Insider program where you can play with some of these features and get early bits and play with them. There's an expo that you can go and we can help you get set up if you haven't done so. I also want to call out that there are 2 other sessions throughout the day that you can go ahead and learn more about other updates to Windows Hello. One is on a deployment that is happening today. And it basically talks about some of the simplifications we've made in terms of deploying Windows Hello, improvements we've done in terms of provisioning Windows Hello, and this is, by the way, Windows Hello for Business. The pin reset and some roadmap about how we plan to support on-premise deployment with Windows Hello for Business. So that's the session number. Check it out. And then there's one more coming on Thursday, which I talked about, which is more about API story and how a developer can leverage our API to build into Windows Hello an app or a browser and also a companion device. That's all I had. I want to thank you all for your time and attending this session. I hope this was educational. If there are any questions, this will be a good time. Yes, go ahead.
Just wondering, you talked about Windows Hello for sign-in. Is there any plans or automation for automated sign-out? So let's say you use your phone for authentication via Bluetooth and you walk away from your device. What's the plan? What's the roadmap? What do you want to expect?
Yep. So the question is, so you have companion devices to sign into the PC. Do you have something to sign out or lock the PC? And the answer is yes. We have that as part of our roadmap where the user can set up their companion device to be a signal that they have walked away. And if they forgot to lock their PC, it will help to lock the PC, yes.
The same thing with the bracelet, same thing
Yep.
with the USB key.
Yep.
You pull the key, does
Yep.
that shut you down?
Yep. That's the idea. Yep. It's part of the next steps you're working on with companion device framework, but yes.
Any idea when that might be released? General idea? So I've got customers that are asking for this type of architecture.
Yep.
They love the framework for the sign-on, but without the sign-off, the sign-on doesn't mean much to them.
Absolutely. We don't have clear timeline, but it will be sometime in 2017. I think being part of Insider program allows us to show you these experiences sooner, and you can play with it. But yeah, this is the next thing we want to work on. Yeah, go ahead.
Do you have the plans for the iPhone as a companion device?
iPhone, so the RSA solution you saw is an iPhone solution. Yeah,
Yeah.
yeah. But there are other solutions that are coming for iPhone too, more than one, but that's the one that is closest to being shipped. Go ahead.
Do you have any plans to remote desktop authentication?
Remote desktop authentication, plugging the companion device framework into it.
Someone sat down, you walked into a local device, but can you then push it on to doing remote desktop as well?
That's, so the question is, do you support RDP with this? And the question currently no, but yes, it's part of the plan to get there. Yeah. Go ahead.
Also, in your VPN demo, you had, I'm assuming, your old style VPN set up and then the new style Windows Auto VPN connection underneath. Does it work with the new Auto VPN?
Yes, it totally does. So had I used my phone to log on to the PC, the VPN connection would have automatically connected without me having to do anything extra. I didn't do it that way because I wanted to show the VPN experience of notification and all that, but yes, it would have totally worked had I logged in with phone
So
first.
literally you can log in with the phone and your Auto VPN will
Yep.
dial without anything.
Without anything, it just works. Yep, yep. So the question is, do we plan to have any Android or iOS? For which one? The one that was VPN or the one that was logging it? The companion was, yes. We have few partners that are building that. RSA is one, but we have others that are building the same thing, yeah. Vanquisys is another one that is building it right now. I think there was a question here. Did I miss it? Yep.
Why is a PIN required for Windows Hello? And, because my enterprise, we don't allow pins. So I was wondering if we could implement Hello without a pin.
So the question is, why do we need PIN for Windows Hello? It's a great question. From our perspective, we wanted to have a fallback for biometrics. You may cut your finger, you may grow a beard, and we wanted to kind of design a solution where it can work in a world with no passwords. And so imagine you come to your PC and you've cut your finger, how can you get to your system, right? And that's the kind of thinking behind you leveraging PIN, and that's where they came from. But I also understand that some enterprises turn off. So if you want to catch me offline and talk about it more, I think I'm eager to know the actual requirements and why PIN is disabled. That'd be great.
If I can, because that kind of sparked a thought in my head. The PIN's not replacing the password.
Right.
The PIN's is a backup for the biometric.
That's right. That's absolutely right. But it seems that in their customer base, they disable PIN, period, right? And I think the question is, can we understand why that's the case and see if we can convince them? Because the PIN that we have with Windows Hello is different from the PIN we had in Windows 8.1. It's completely different. It has support for policy. You can set it to be complex. It works with TPM. So I think I want to understand where that requirement comes from. Yes, go ahead. So this is any companion device. There will be like a text box that says, "We just send you a text message and show it." That's an interesting idea. We haven't heard that from our partners, but theoretically it's possible. Our framework has to be changed a little bit to provide them that text box to collect that OTP, but theoretically it's quite possible because as you can see, it's an app. The app can talk to anything at once, and now we need to understand the threat modeling behind that, because one of the things we do is to make sure your companion device is present when unlock happens, but if this is just an OTP, how can we continue the same guarantees? So it's an interesting idea, but we haven't quite thought this through, yeah. But it's possible, yeah. All right, that's all we had. Thank you again, guys. Really appreciate your time.